Hello guys, hope all of you are doing great. In our previous video, we have seen how we can declare variables in 8086 programming, and also we have seen how we can store immediate data, like store some values there in those variables, and then how we can copy the content of a variable to a register, and then again how we can copy the how again we can copy the value of a register back into a variable. So all these things we have seen in our previous part of the video. Now in this video we are going to make use of those concepts, and we're going to write this simple program. In this program, what we're going to do is we'll write a program that declares three variables, a1, b1, and c1, and then store some immediate data in a1 and b1, say for example 5 and 6. And after that, using 8086 instruction, we'll be computing the sum of these a1 and b1, and then we'll be storing back the result in the variable c1. And after that, we'll be verifying the program in debug mode. I might be thinking, why not display the output of the program directly and verify the program? So for that, what I have to say is that displaying some numbers, I mean displaying the value of some variables or registers in 8086 program on the screen is not as simple as as it is in C programming language or some other high-level programming language. So for example, in C, if you want to display the content of a variable, then what you do is you just write printf percentage whatever the format of that data type, like say integer means percentage d, and then the name of the variable. But here in 8086 programming, things are slightly, I say, not complicated, but the thing is that you have to write a few more lines of code to display something on the screen. So I'm keeping that thing for my future video. So here right now in this video, we'll be concentrating on on the demonstration of the use of variables in 8086 program. Okay, then let's begin. So for that reason, what we're going to do is we're going to open Visual Studio Code, and there we are going to create this file. So let me call it pp4.asm and press enter. The file is created. Again, I'm starting from the beginning. I'll start with this model small, and then we'll be using data segment, which I'm going to fill in a moment. And then the stack segment, we are not using it directly for the time being, so I'm keeping again the explanation for this stack segment for my future video. And then the code segment. Here, let's say the program does only one thing: it starts and it ends. I'm just writing the skeleton for the time being, so obviously when the minimum program is, it should be able to terminate itself. And how do we terminate a 8086 program? Yeah, these are the few lines that we have to write. First thing that we have to do is we have to move to a H register 0 for CH, and then we have to call this interrupt service routine int21h by writing this instruction int21h, and then this is the end of the program. Okay, this is the basic skeleton. And then what we need to declare three variables. So, and let's say for example here, those variables are of 16-bit. So we'll be doing it in this way. Say the first variable is a1 and it is of 16-bit, and initial value of this variable is 0. Similarly, b1 of size 16-bit and 0. And say C1 of 16 bits, and say initial value is 0. Done. We have declared three variables. And actually, see, in the program, it is said that declare three variables and store immediate value 5 and 6 in B1. So at the time of declaration itself, I can write here 5/8 and 6/8. Or what we can do is in the code segment, actually we can use move instruction to store this immediate data in those variables. And I will be following that approach. Okay, but again, as I said, no, here itself directly the initial value I can write 5/8. But just to make use of those move instructions, I'm writing it here. So first thing that we're going to do is move. We want to store 5 in A1. So I can write it directly in this move to A1. I have to move 5H. So I'll be writing 05H in this case. Similarly, we'll be writing move to B1, say 06H. And again, I'm saying like these numbers 5 and 6, they are same in hexadecimal as well as in decimal. Up to 0 to 9, there's no problem. Only the differences starts from this number 10. Like 10 in decimal is 10, but in hexadecimal it will be written as A. Just for simplicity, I'm using within that range 0 to 9. Now done, like 5 is copied to A1, 6 is copied to B1. Then what we want to do is we want to compute the sum of these two variables. So we know the instruction is add instruction. So we'll be using this add instruction, and then see here, this add instruction, okay, let me explain this add instruction in a moment. Just 1 minute, I'll be explaining it. Say these add is the name of the instruction, and then here you will be writing operand 1. I'm just writing here O1 comma O2. See, as I said, no, this add, you can think of it is the plus operator. Okay, and say when you want to write say O1 plus O2, you'll be writing add O1 comma O2. But again, there is one more thing. See, usually what happens, say for example, you consider a high-level programming language like C. Usually what happens is like when we compute the sum like this, or two variables, sum of two variables like this, usually we want to store the result of that expression in some other variable. Say for example, O3, or maybe in any one of these variables. Say for example, this is also valid. We can write like O1 plus O2 like that. But usually we write these addition as an expression where first we compute the sum and then we store the result back into some variable for some future references. But here if you see in add instruction, the thing is that it needs, okay, you can specify both these two operands, but suppose you want to store this result back in some one, in some variable, then how do you do that? Now that thing is actually implicit here. When you write add O1 comma O2, it means what you're doing basically is you're writing O1 is equal to O1 plus O2. Whatever it is, this operand here on this left hand side, there it's in that operand itself, or in that variable itself, or in that storage itself, the result will be stored back. Okay, so that thing you should realize. So it means what? If you like, see here, you just assume you cannot write 5 is equal to 20 plus 6. Why you cannot write it? Because you see 20 plus 6 is 26. That is okay. There is no problem with that. But the thing is that you cannot store 26 in again some intermediate, immediate data. 5 is an immediate data. I mean, 5 is just the value. It doesn't represent any memory location. So this statement is wrong in high-level programming language. So same way, you cannot write like add, you cannot write add, say 5h, comma, some register, the content of some register here, AX, say. Why it is wrong? Because as we know, this operand is actually at the same time, it is used as the storage for the result. Whatever it is the result of this add expression or add instruction, the result will be stored back on this left hand side operand. So that way, here whatever you write, that should represent some memory location, some storage. It could be a register, or it could be some variable name, say for example O1 comma O2. That is the first thing that you need to, that is another thing that you need to take care of. One more important thing about these add instruction is that, say you can write these other operand. Now we fix like the first operand could be a register, or the first operand could be a variable also. And let's talk about the other operand then, what these other operands could be. The second one. So it could be obviously immediate data like 5h or 6h, or it could be a register, or it could be the name of a variable. So this second register could be any one of these things. Like it could be immediate data, it could be a register, or it could be a variable. So out of all these possible combination, one thing is invalid. The invalid combination is variable. When the first operand is variable, then the second operand cannot be a variable. Only this thing is not possible. Other than that, everything is possible. So you cannot write add O1 comma O2. So so that's the only one combination which is not possible. Other than that, more or less all the other combinations are valid. Okay, let's now try writing this code. Okay. What we'll be doing is we want to add. So as we have seen that we cannot write actually add A1 comma A2. Oh, sorry, A1 comma B1. Let's write this thing and see whether we can execute this program or not. So I have written this program. My autosave is on. In your case, if it is not on, you click save button there and let's execute. Open that Tasm software. There you, I'll be exiting from this full screen mode. And then here I'll be writing Tasm pp4 is my program.asm. As soon as I write here, I try to compile this program. You can see here in line number 14, illegal memory references. Let's see what is this line number 14 is. This is my line number 40. It means this particular instruction is not a valid instruction here. As I said, now both these operand 1 and operand 2, they cannot be at the same time some variable names. Okay, at least one of them should be a register. Okay, so if it is the case, then what we can do is, okay, let's copy these A1 to AX register. So I'll be doing it in this way. Move to AX register, copy the value of the variable A1, and then use add instruction. Use AX as as operand 1 so that the result gets stored back in the AX register, and then B1. That is, add the content of the variable B1 with the content of the register AX and then store the result back in AX register. What this add AX comma B1 will be doing at the end, it will be interpreted in this way. Let me write it here. This add AX comma B1 will be treated as AX is equal to AX plus B1. Whatever it is value of, it is the value of this variable B1, then whatever it is the value of the variable AX, both of them will be added up, and then the sum will be, the result will be stored back in this AX register. Done. And after that, what we are going to do is, okay, now the result is in AX, but where we want the result? We want the result back in the variable C1. So for that reason, we'll be writing move to C1, actually, move to C1, the content of the AX register. And that's the end of the program then. We are done. Like whatever it is asked in the program, we did that. Now let's execute this program and check whether the program is right or wrong. I mean, whether it is behaving in the same, in expected way or not. Okay, let's see it. So this is a program right now, and I'm going to compile the program. Right now, no error, no warning. So it means the program is compiled. And then we'll be linking the program. So t-link, this is the next step. So pp4.asm is not needed. Done. And then it is ready. We can execute it in debug mode, td pp4. Okay, let's see. What we see again, this is the code segment of our program, actual code segment that we wrote actually, and this is the code segment like in the Tasm editor. Okay, anyhow, let's see. Move A1, 058. As we have seen in the previous video also, these variable names will be replaced by their offset address in this way, word pointer 000A. It means in data segment register, in data segment at the location, at the byte number 000A, we want to copy this number 5. Similarly, move B1, CH. It means B1 is actually replaced by B1 is there at this particular byte number 000C in data segment. So there we want to copy 6, and then whatever it is the content of A1. See here, A1 means the memory location 000A in data segment. So whatever it is the content of that particular memory location or that particular byte number in data segment, from there we want to copy 2 consecutive bytes to AX register. Same thing we want to do uh, in AX register, yes. And after that, the next instruction is add AX comma B1. It means whatever it is the content of this C, byte number C, from there 2 bytes, we want to add that particular word with the word which is there in AX. And after that, obviously, the result will be stored back in AX. And at the end, what we want to do is we want to copy the content of this AX register to C1. Now, say C1 is a different memory location now, byte number 000E in the data segment register. Okay, let's now execute the program. At the count of 3, I'll be pressing F7. So as soon as I press F7, the first instruction which will be executed is move to this particular location 5. Now see where is this where we can expect to see some changes here. Okay, let's see that. Say 000A. So it is 000. This is 8. Byte number 8, byte number 9, byte number 10, which is A. 000A. So this is the lower byte and this is the upper byte. So as soon as we copy 5, the lower byte will contain 5, the upper byte will contain 0. So as soon as I press F7, you'll be seeing a change here. Okay, at the count of 3, I'm going to do it. 1, 2, 3. Sorry, 1, 2, 3. Now see, as soon as I press this F7, you can see that, okay, the lower byte here at A, see here, this is 8, this is 9, this is A. The lower byte is 0, 5, upper byte is 0, 0. So that's copied. Now again, I'm going to press F7 at the count of 3, and that time, as now where we can expect the change, we can expect the change starting from byte number C. So which one is byte number C? Let's see here. This is 8, this is 9, this is A, this is B, this is C. So from here, these two consecutive bytes will be changed. So as a result, this C5 will become 06 and this 15 will become 00. So as soon as I press F7, you can see a change. You can see some changes here in these two consecutive bytes. Okay, ready? I'll be pressing it at the count of at the count of 3. Okay, 1, 2, and 3. See here, this 6 is copied as the content of the lower byte and 00 as the content of the upper byte. Now, the next instruction that will be executed is copy the content of byte number A to AX register. Now see here, this move instruction is involved here, this AX, that is a 16-bit register. So as a result, this entire instruction will be a 16-bit instruction. What does that mean is, this byte from byte number 000A, the content of two consecutive bytes will be copied as the content of the register AX. Let's see it. 000A is this 8, this is 8, 9, 10. 00, this is A, this is 11B. So 05 will be copied as the content of AL register. 00 will be copied as the content of AH register. Right now you see the content of AX is 0000. So as soon as I execute this instruction, the content of this AX will be, the lower byte will be 05, upper byte will remain 00. So at the count of 3, I'll press F7 and you just keep your eyes focused here and you will see this 00 will change from 00 to 05. Okay then, ready? I'll be pressing it at the count of 3. 1, 2, 3. See here, as soon as I press F7, you can see this 00 is changed from 00 to 05. Now, the same thing we are going to do now. Now see, the next instruction is add AX, 000C. What it will do, it will first see whatever it is the content of the register 000C. So it is this is 8, 9, A, B, C. C is lower byte is 06, upper byte is 0. So ultimately C is 6. Now that 6 will be copied with the content of this AX register. AX is now lower byte is 5, upper byte is 0. So basically 5. So what it is going to do is it is going to add this 6 plus 5. So 6 plus 5 is 11, which is in hexadecimal B. So that B will be copied as the content of the register AX. So it means here, as soon as I press F7, you will be seeing this 0005 will change from 5 to B. 11 means B, so B. So it will become B. Okay, let's do it and see. At the count of 3, again, I'm going to press F7. So 1, 2, 3. Now you can see this is now B. It means the result is now stored there in this AX register. Done. What is the next instruction? That is move 000E, comma AX within square bracket, comma AX. Now see, the corresponding instruction that actually we wrote in our program was move C1, comma AX. That is, we want to store the content of the register AX as the value of the variable C1. So that's what this instruction ultimately will do. It will copy the content of that AX register to the memory location 00 or to the byte number 000E in the data segment. Let's first see where is this 000E. This is 8, so 8, 9, A, B, C, D, E. So this is E. AA, this is the lower byte of, starting. This is the byte number starting at E, and this is F, byte number, uh, 15. This is byte number 8, 9, 10, 11, 12, 13, 14, 15. E is 14, F is 15. So E means here. So this lower byte will change from AA to 0B, and this upper byte will change from 01 to 00, because we are going to copy the content of this AX register to these two consecutive bytes. So this lower AL will be copied to this E register, E byte, and this 00 will be copied. AH will be copied to this F byte. Okay, let's see. I'll be pressing at the count of 3 again, this F7 key. So you just keep your eyes focused on these two bytes. Ready? Okay. 1, 2, 3. Once again, 1, 2, 3. So here, as soon as I pressed F7, then you can see 0B is now the content of the E byte, and then 00 is the content of the byte number F, that is byte number 15. Okay, so now after that, the next instruction is move AH, 4C, that like will be now this will copy 4C to AH register, where you should keep your eyes here. AH 4C, I mean this 00 will now become 4C. I'm pressing F7. Now you can see this is 4C, and then after that we are calling interrupt service routine, by writing in21H. So that interrupt service routine, if 4C is there in AH register, it means that we are calling the routine that marks the end of the program. Okay, that terminates the execution of the program. So I'm pressing F7. That will show, okay, this is the end of the program. I pressed most probably the wrong key. Sorry. Okay, but anyhow, that should be the end of the program. Now, what we saw here in this demonstration is how we can declare variables, and then how we can make use of those variables to do some computation. Here we did a very small computation, like finding the sum of two numbers. So in the next video, what we're going to see is how we can display how we can display something on the screen. Rather, what we're going to see is actually we're going to see these interrupt 21, INT21 instruction in some more details. This instruction will be involved when we'll be displaying some content on the screen. This instruction will be, this instruction will come into play. So in other words, you can say that in the next video, we are going to learn some more use of these INT21 aids. Okay then, till then, have a nice day.